All right. Hi, everybody. I'm here to introduce our speaker today, Cameron Prophet, who was a 2005 graduate of Alfred Central School, and then went on to get his BAFA at Alfred University here. Grew up in Alfred. Has a lot of his family here today, which is great. We have the Cameron Prophet family fan club here. And he has been working for the last 5 years, I think, as lead in an invasive species group at the Grand Canyon. So we're really pleased to have him. He just happened to be coming back this weekend, so I grabbed him for, well, I asked him to come give a talk. He said, I'm coming back that weekend, so we chose that weekend, this weekend. And at the end, we will take questions from the in-person audience first, and then we will, if people on Zoom can put their questions on chat, we'll talk about the questions that are on chat from the Zoom people. So without further ado, I'll hand the microphone to him.
Can everyone hear me? Excellent. Great. So I'm Cam Prophet. I'm actually the Invasive Plant Crew Lead at Grand Canyon National Park, and I have been since 2016. And I started as an intern in 2015 and worked my way up from there. So I did grow up in Alfred, went to Alfred University with a Bachelor of the Arts and Fine Arts program. And I came back in 2013 and attended Alfred State for a short period of time to brush up on some biology and mathematics. And so before we get started too much, I do want to acknowledge that Grand Canyon is the traditional lands of Indigenous native groups, including the Havasupai, the Hopi, the Wallapai, the Kaibab Band of Paiute Indians, the Las Vegas Band of Paiute Indians, the Moapa Band of Paiute Indians, the Navajo Nation, the Paiute Indian Tribe of Utah, the San Juan Southern Paiute Tribe, and the Pueblo of Zuni, as well as the Yavapai Apache Nation. And just a note here too, Grand Canyon is far richer in cultural history, both ancient and modern, than much of the short span that white settlers have claimed it. Additionally, in a great note for modern times, Indian Garden in Grand Canyon was recently renamed Havasupai Garden through the work of our superintendent, Ed Keeble, a good step forward. So just to give a very quick overview of the natural history of Grand Canyon. This is a very quick overview. It was formed about 5 to 6 million years ago across the Colorado Plateau. That was from down cutting by the Colorado and other small rivers, prehistory really. There's about a 5,000 foot difference between the rim and the river. It's essentially 1 vertical mile from the rim to the baseline at the river. And due to this elevation, we have 5 out of the 7 life zones that are represented. Within those life zones, we're going to be mostly talking about the warm desert and the semi-desert grassland, but Grand Canyon also encompasses the pinyon juniper woodland, the ponderosa pine forests, and mixed conifer forests. Because of that elevation difference, that elevation change, we have about 1,700 documented plant species there. And though that's the official, closer to the official number, it is only slightly lower than the official number of plant species and plant diversity in New River Gorge in West Virginia, which actually holds the highest plant diversity within the National Park Service. However, we do believe that there are at least 200 to 300 more species that have not been documented yet. And that would then make Grand Canyon the most diverse in-plant species in the National Park Service system. So here's a representation of the life zones in Grand Canyon. And so between the dotted lines there, you can see it spans from the mixed conifer forest to the warm desert. And again, most of this discussion will be focused on that warm desert life zone down at the river. Keep in mind as well that elevation is only part of the story, and that latitude within our own country also plays a part. And so if you're traveling from that mixed conifer forest all the way down to that warm desert, it would be like traveling from Montana and then ending in South Texas. All right, so a quick history of the park as well. It was designated as a national monument in 1908 by Teddy Roosevelt after his visit in 1906. And he did say, "Let this great wonder of nature remain as it is now. Do nothing to mar its grandeur, sublimity, and loveliness. You cannot improve upon it, but what you can do is to keep it for your children, your children's children, and all who come after you, as one great sight which every American should see." Finally, it was designated as a national park in 1919. It was signed on by Congress and signed into law by President Woodrow Wilson. And so to create a national monument, all a president has to do is make a proclamation. To create a national park, Congress has to agree to it as well. And so that's why it took so long. All right, so the Colorado River is the reason for Grand Canyon. And it used to flow freely from what is now central Colorado through Utah and Arizona, and defining the borders between Arizona, Nevada, and California. Along its route, it's fed by the Green, the Gila, the San Juan, the Little Colorado, the Dolores, Gunnison, and the Virgin Rivers. And it used to flow all the way out to the Gulf of California. Due to damming, drought, and the use of water, overuse of water, the river actually no longer connects to the Gulf. And so in 1931, construction on Hoover, which is also called Boulder Dam, began and was then completed in 1936. This really was a really amazing feat of human engineering and partnership. It's really an amazing structure despite its ecological issues. And this created Lake Mead. At its fullest, Lake Mead backed up about 112 miles, 40 miles of which were in Grand Canyon up to what's called Separation Canyon. So in that western part of the river, you'll see the U-bend. That's about where Lake Mead has backed up to in the past, and it is receding slowly. In 1956, there was the construction of Glen Canyon Dam, and it was completed in 1963. Lake Powell, which was created by the Glen Canyon Dam, was 186 miles long at its full capacity in 1980. And both of these, incidentally, are the two largest man-made lakes in North America. So, excuse me, in the United States. In the 1940s, prior to the construction of Glen Canyon Dam, the Bureau of Reclamation began prospecting 4 sites within Grand Canyon proper to build a series of small dams to generate more electricity and create recreational opportunities akin to Lake Mead. Glen Canyon Dam was the result of negotiations between the Bureau of Reclamation and the public conservation organizations that wish to preserve Grand Canyon. So the creation of that dam was really kind of a hostage situation with Grand Canyon. So Glen Canyon Dam itself regulates the flow of water through Grand Canyon. Higher flows of water allow for more production of electricity. Lower flows of water keep Lake Powell full. And so this creates tides, essentially, down on the river. And these tides flow in ranges from about 20,000 cubic feet per second. Whoop. Yeah, from about 20,000 cubic feet per second to 10,000 cubic feet per second on a daily basis. And so just to put that in perspective, 1 cubic foot is approximately the size of a basketball. So imagine 20,000 basketballs rushing past you at any given moment. That's on a daily basis, though. Boat operators on the river refer to this as the bulge as it moves through the canyon. And so this graph here, if you look, it does show it's from 2014, sourced from USGS. That is the regulated flow demonstrated on the river. Prior to Glen Canyon Dam, however, the daily flows were about 100 cubic feet per second, okay? What we would almost consider barely a trickle. But then they ranged all the way up to over 100,000 cubic feet per second in major yearly floods. So prior to landscape scale influences, we had these very minuscule flows. We had these very major flows. And I do recognize that this chart is in meters per second rather than cubic feet per second, and I apologize for that. But the arrow does show 1963 when Glen Canyon Dam was put into place. And you can see how much those flows have changed in that time. So those 100,000 and up flows would then scour out a lot of the native vegetation in the canyon, literally rip it right out of there, flush it down into what is now Lake Mead and before Boulder Dam throughout the rest of the Colorado River and out to the Gulf of California. Because of that, there were a lot of shifting sandbars and beaches, and we're trying to kind of restore a lot of that ecology back in. We're essentially fighting ourselves with the dam. So this is important to know because the Park Service mission is to preserve unimpaired the natural and cultural resources and values of the national park system for the enjoyment and education and inspiration of this and future generations. We really have a duty to maintain those natural and cultural landscapes within our boundaries, despite the outside influences that may have an effect on the resources that were given to each park unit. And so we have the long-term, long-term experimental management plan. It used to be called just simply the adaptive management plan. And this was a coming together of the USGS Grand Canyon Monitoring and Research Center in Flagstaff, as well as the Grand Canyon National Park Office of Science and Resource Management. And so we have 4 main projects that we work on with LTEMP. The first is to control non-native plant species affected by dam operations, and that includes tamarisk and other highly invasive species. We want to collect plant material and replant native plant species to priority sites along the Colorado River, including native species that are of interest to tribes. We want to remove vegetation that's encroaching on campsites. We want to manage vegetation to assist with cultural site protection. So objective 1, we're going to remove or at least try to control non-native plant species affected by dam operations. And so to this date, there are 206 known non-native plant species that have been documented within Grand Canyon National Park since 1936. And that work was actually started by one of our very first ecologists, whose name was Edwin McKee. About 50 of those plants can be found down by the river growing. Based on all of our projects and issues, we are trying to focus what we can on those plants that are easier for us to control and within our means. So we have Russian olive, we have camel thorn, and we also have tamarisk. And it looks like my settings are a little off here. I apologize. Okay, so Russian olive was introduced across the country in the 1940s and throughout the 1970s. It was introduced as erosion control, bank stabilization, and things like that in metropolitan areas. And you know, years ago, when I came back to visit, we went to my grandparents' house and actually saw that the roads department had planted several Russian olive trees down in their creek at one point. And so from these areas that various public works departments were trying to keep erosion from occurring, these plants have now spread into wilderness areas. Camel thorn. This was inadvertently introduced into the US through alfalfa seeds. It's now spread throughout the southwestern United States. It really has a great penchant for finding the most disturbed, sandiest soils. It also has needles that are about 1 inch to 3 inches long that will go straight through a pair of field pants. It's definitely a very lovely plant. Large populations in the canyon are still growing and proliferating, and we are experimenting with and finding new ways to knock it back as much as we can. And then the third plant that we're trying to focus on is tamarisk. There are several different species of this. We do focus on one in particular, Tamarix ramosissima. Another common name for this is salt cedar. Tamarisk was introduced in the late early 1900s in the Midwest. It was used as windbreaks. It was also used as erosion and bank stabilization controls throughout the Southwest, including California. It is somewhat what's called allelopathic, and that just means that it is able to produce chemicals that make it harder for other plants around it to grow. And so in this case, it accumulates salts in its leaves, and when the leaves drop, it makes the soil around it salty and harder for other plants to grow. I will add that with tamarisk, it does grow right down at the river, and it does happen to grow in a lot of the back eddy areas that we're trying to preserve for the southwest willow flycatcher and a number of other native bird species. And so we're actually not allowed to treat mature tamarisk down on the river. So objective 2, this is collecting native plant material. And we have a number of different plants. I'll go through each one at a time. This is Fremont cottonwood. There's a little bit of controversy over Fremont cottonwood. There's no doubt that it is native to the Southwest, but whether it is actually native to the canyon is a source of contention with the vegetation program and some of the cultural resources programs. However, this tree was planted in a lot of the areas where early white settlers were mining or forming camps for recreation. And the reason for that is it grows to a massive size. It also grows very quickly, and it has very broad leaves that produce a lot of shade. And so that's one of the reasons we want to keep it as well, is for recreational opportunities for people who are hiking into the canyon, especially in these places like Havasupai Garden. We also have Gooding's willow. This has the ability to grow very large, about as big as cottonwoods. It is preferred to cottonwood since we do know it is a native species, and it does fill an important habitat in those lower backwater eddies that have been overtaken by tamarisk. And so therefore does support southwest willow flycatcher and other native bird species that need those areas for insect breeding. We also have honey mesquite. It's a major species for the hottest and driest parts of the riparian corridor in the canyon. It's an important source of food and wood for early peoples who lived in the canyon. So that helps us to work with some of our tribes on putting back some of the traditional landscape that we've lost due to the dam. This is velvet ash as well. It's considered the best replacement for cottonwoods due to their height, long life, and ability to give shade. It's also a great part of side canyon and side stream ecology. Cat claw acacia. This is not the favorite plant of our wildlife techs who have to climb through it quite often. Along with honey mesquite, it's a good plant for extremely arid areas, and but it does not provide as much shade. It's actually a much shorter plant, and it's more scrub or bush-like. And so within objective 2, we do have Cardenas Camp down on the river. If you look closely at this slide, you might be able to see the river there in the kind of middle ground below those buttes. Cardenas Camp is one of those places where we are trying to build up this restoration site, not just for recreational purposes. This is one of those back eddy areas where there used to be backflow channels prior to the dam, the creation of Glen Canyon Dam, where Southwest willow flycatcher food by way of insects would be breeding. Let's see. We also have Granite Camp. This is a bit more of a focus on the recreational possibilities of Grand Canyon. It has a pretty major trail, the Hermit Trail, that goes right down to it. And it's also a major camp for boaters. But aside from that, it's also a feasibility study on removal and replacement of tamarisk, especially with a lot of our Gooding's willow and some of those other native species that I mentioned before. So objective 3, remove vegetation that's encroaching on campsites. Because of those flows within the river that I mentioned earlier, a lot of these plants have, whether they're native or non-native, they have regenerative roots. And this species in particular is called arrowweed. You can see that that's the kind of fluffier stuff, silvery fluffy stuff in the foreground growing on that beach. Arrowweed has a very long rhizome. It's just a lateral root that grows just under the surface, and it does regenerate very easily. And so the purpose of removing this is almost strictly for recreational boating purposes. This objective does, however, fit nicely with objective 1, since most of our non-native invasive plant species are growing alongside these native invasives that we're targeting, including the arrowweed. And so this is a before and after photo, one of our photo points. So we also have an objective 4, which is to manage vegetation to assist with cultural resource site protection. We refer to this as the Cultural Resource Aeolian Transport Project, or CRAT. We do like the acronyms in the government. This is being done in collaboration with the Grand Canyon Monitoring and Research Center with the USGS and Flagstaff. They actually have a lot of mapping and they share quite a bit of information with us. It's really a great organization. So the point of this project is to actually remove as much vegetation from a few key sites as we can to allow for the wind dispersal of some of the beaches that have formed after the creation of Glen Canyon Dam. What this does is create dunes upslope that then cover cultural resource sites and protect them from erosion as well as looting by visitors. So most of these are additionally associated with recreational campsites. And so we're often completing 2 or 3 tasks at the same time within all of these objectives as we're removing them, as we're removing plants. And so we do use what we refer to as a transect array method for mapping and cataloging the work that we've done and completed. And so transects at each site are taken using an array mat, which has 16 lines on it, coming from an out center point. We put the mat down at a predetermined GIS location within each site. Most sites only have 1. We do have a few sites that have up to 3 of these predetermined GIS points. Line 1 on that mat is always oriented toward true north. And then we take photo points in the 4 cardinal directions. And that just helps us for the future to see where we are, where we've come from, and where we're going in terms of the work that we've been doing at each of these sites. And so prior to vegetation removal, we take those photos. Each line from the center of that point extends to the edge of the what's considered to be the campable area, or 25 meters, depending on the site. Each plant species object or the river is recorded at the end of each of those lines. And where woody vegetation intersects the tape, we record a break. That includes distances along that tape, and that's then subtracted by the total. This is kind of a hard concept to explain without pictures. So if you look down in the lower center there, that's our mat. And this is actually oriented due north right now. And so we run that tape all the way up to the mesquites in the background. And any plant that intersects it between the mesquite and the mat, we record that distance. And that's going to be part of what's removed with each of these sites. This site in particular is both a campsite, so an encroachment mitigation site, a non-native species site where we are allowed to remove tamarisk, as well as a cultural resource site. So this one is interesting in that it fulfills 3 of those 4 objectives that we have. And so the plants that you see in the foreground again, those are the regrowth of arrowweed from last year. This picture was actually taken 2 weeks ago while I was on the river, and it's regrowth from our 2020 treatment. Yeah, so it is looking upslope toward that dune that we're helping to try to create with that aeolian transport project. And I'll just flip through a couple other pictures here. So the picture in the upper left is facing eastward, and the picture in the lower right is a different transect array point on the same site facing northward as well. So treatment for encroachment mitigation sites removes all woody invasive vegetation, whether it's native or non-native. The CRAT sites remove all woody vegetation, whether it is invasive or not, and that's in order to support that wind transport of sand to create those dunes. In addition to all of this, we have 3 sites where half of the plants are treated with herbicide and the other half are not. This division usually happens along a specific dividing line, such as the north-south line or the east-west line, depending on the site. And we've begun this as part of a project that's also a collaboration with the USGS, GCMRC, and Flagstaff to determine the effectiveness of our herbicide treatment methods in an area where the herbicide was not specifically designated or created to be used in the first place. We only have preliminary data, but the sites do show that at least 70 to 75% effectiveness of that herbicide method, which is roughly equivalent to other areas and other methods that are used for that herbicide. If anyone has any questions about this at the end, I'm happy to talk to them a bit more and answer those. So post-treatment, photo points are then taken. Again, after all the vegetation has been removed, once again along those 4 cardinal directions. Measurements are taken again from that center point along each of those 16 array lines. And within those measurements, again, we determine the uncampable, go up to the edge of the campable area, or the edge of what's considered to be the uncampable area, or 25 meters, whichever happens first. The plant species object or the river at the end of each line is then recorded. And any plant species, boulder, or obstacle that forms an uncampable area is recorded as a break using the same method as before. And so here we have pre-treatment. and post-treatment. And so these slides compare before and after treatments. In this case, all woody vegetation has been removed from this beach and dune side to support the wind-driven growth of the dune over a particular cultural site. Our partners with the USGS GCMRC then continued remote sensoring to monitor the growth of each of these dunes that we've been working on. They also share quite a bit of information with us on many other projects as well. They're really a very wonderful partner to work with. So some of our results. We do have a pre and a post array diagram that we can generate. And we also have established a way to determine the amount of campable area that we're regaining. We do say campable area, whether this is an aeolian transport site or whether this is a non-native invasives removal site, or all three with the encroachment mitigation sites as well. So if you look at this graph, this lists a number of our different sites. And you can see the amount of space is there in that dark column, the black below. And then the post-treatment available space is then shown in the gray. And so places like Basalt Camp, both A and B, just an incredible amount of vegetation has been removed, trying to support that natural ecosystem that we've lost due to the dams. And then we can also draw these sites. And so this is, again, is Basalt Camp and cultural site. That's the dune that we were looking up in that previous photograph. Each of these green dots, both of those green dots are the center point for each of our arrays. The red that you see there is actually the pre-treatment distance that we were able to travel with our meter tape prior to treatment. And then the green is all the space that we've then opened up. USGS does have a monitoring station upslope where they measure the wind persistence and a number of other things, which is what helped us to determine this was a good site to test out the cultural resource aeolian transport project as well. So future work. We will be continuing these river missions over the next few years. We do report what we do to the Bureau of Reclamation, since they do fund a lot of these projects for us. We work very, very closely with a number of Arizona conservation corps, but specifically the Ancestral Lands Conservation Corps. That is newly formed. It used to be nestled under a number of other conservation corps, and it's now its own entity. This is for young Native peoples to go into national parks or other areas, including national forests and really just public lands, and do work that relates to conservation in those areas. And that doesn't just include manual vegetation removal like we do. It's also interpretation and trying to kind of bring the Native voice back into these areas. And then, of course, we also work with GCMRC, the Grand Canyon Monitoring and Research Center, a lot as well. Future tasks that we'll continue to do are site revisits to each of these sites that we treat. It'll also include continuing treatment of those invasive plants, the vegetation encroachment, and the cultural resource site protection with that aeolian transport project. We'll continue to monitor treatment and treatment effectiveness, again, compared to herbicide use versus non-herbicide use on some of these native plants. We'll be selecting future revegetation sites. We're hoping soon to be adding about 3 more restoration sites down on the river, especially down on the lower half of the river, which is a little harder to get to and a little more wild at this point. And we'll be continuing to collect native plant materials to support those revegetation sites. And so back in the late 1950s, this gentleman, Martin Litton, was one of the early representatives of the Sierra Club and a number of other outdoor organizations. He was a river runner in the early days prior to Glen Canyon Dam. My mother tries to tell me that he was crazy. I think, yes, he probably was, but in the best possible way. And so people always tell me not to be extreme. Be reasonable, they say, but I never felt it did any good to be reasonable about anything in conservation, because what you give away will never come back, ever. He died recently in 2014, but despite his death and you know, the re-ownership of his organization and everything, with the Park Service mission and vision, we are trying to do the best that we can to revegetate a lot of these places, to devegetate those places that are now overgrown due to dam operations. And with that, if anyone has any questions, I'm happy to answer them from the audience. Yes. Yep. Yes. Right. So the question was, what do we do with the vegetation once we're done with it? That's actually a point of contention with our program and our compliance office right now. Throwing it in the river is what we used to do. That actually helps with a lot of native fish habitat and is really good for that river ecology. A lot of our river guides, especially those that run motorized boats, don't like that because it does have the possibility of getting tangled up in the motors and everything. Currently, for the very first time on the last 2 missions that I was on just prior to coming out here to give this talk, we were piling it up on shore above what's called the high water mark. Old high water mark, meaning prior to the creation of Glen Canyon Dam. That is not sustainable. We are doing the best we can to work with our compliance office and raising some of the awareness of what we're doing and why we're doing this among the river community to try to help us in supporting either throwing it back in the river or finding better solutions for disposal. So thank you for that question. Yes.
How many of these sites are accessible by foot? You actually have to hike down to it. How much does that take? How many of them are only accessible by getting on a boat at least ferry and traveling down?
Sure. The question was a logistics question again about what sites are available via hiking into the canyon and which sites are available only by boat. The answer is complicated. Most of the work that we do on the river is done by boat. We do take, it's usually a 37-foot, it's called an S-rig, so 37-foot long motorized boat. And we have anywhere from 5 to 10 people on that boat that we work with. That's really the most efficient way for doing this work. We can hike down. It usually takes at least a day of hiking to get there. And then we also have to carry all of our equipment with us, including herbicide and food and everything for those few days. Grand Canyon is a very, very hostile environment. It's very steep. I've had knee surgery in the last year, partly due to that, partly due to childhood injuries. But yeah, the most efficient way is for us to use a motorized boat. The 2 restoration sites that I showed, one of the reasons that we have those sites in those areas is they are accessible both by boat and by hiking. And so last minute issues that we have to deal with where we don't have the time or the funds to get a river mission approved, we will hike down to those places to do the work. So. Sure. So the follow-up question is, what's the minimum number of days that we would spend on a boat? My shortest river mission, that was a full river mission from Lee's Ferry to Pierce Ferry, 280 miles. My shortest one was the most recent one, and that was 18 days. Excuse me, 16 days. The longest one that I've been on was 21. So, and that is, except for Phantom Ranch, which is right in the corridor of the developed area of Grand Canyon. That is almost entirely wilderness, or at least proposed wilderness. It has not been approved as wilderness yet by Congress, but we're hoping someday it will be. Yeah, it's very inaccessible. It's quite a wonderful experience too. Yes?
How did the invasive get here? And where did the growth come?
Sure. So a lot of these invasives came in various different ways. The non-native invasives, most of them were brought in by, they came kind of naturally on their own accord in one form or another, in the usual way that invasives spread. A lot of them were introduced to other parts of the Southwest, either for erosion control or bank control of stream banks and things like that. In terms of our native invasives, we do have like the arrowweed that I mentioned before. Arrowweed is one of those plants that in those 100,000 cubic feet per second floods would then have been ripped out and redistributed throughout the canyon at least once a year, usually, prior to the creation of Glen Canyon Dam. And so that one's native. The only reason it's become invasive is because the conditions down there have changed. So, but things like tamarisk and Russian olive and camel thorn have all come in through human means in one form or another, and then begun to spread naturally on their own. So, yes. Yeah. Sure. So the question was, what is the park's relationship with some of the tribes? It's not great. It is a lot better than a lot of other tribes and, or excuse me, a lot of other parks and a lot of other tribes. Our neighbors to the west, the Wallapai, are not particularly happy with the way the park has been managing the river corridor in particular. And they also do believe that there's a kind of controversy about where those boundaries should have been drawn, where they are drawn currently. This season, I've worked very, very closely with a lot of Native youth through that Ancestral Lands Conservation Corps program, specifically the Zuni, the Navajo, and the Apache. You know, as young folks working in conservation, they are absolutely my favorite people to work with. You know, there's a lot of good humor. There's a lot of understanding between us about why we're working in these situations, why these places such as the national parks have been set aside, but also still a lot of frustration and anger from the socioeconomic side of things, where these people were removed from these areas in one form or another. So, yeah. Yep. Oh, so we have a question similar to Lena's. How are local Indigenous tribes regaining rightful access to the canyon? Speaking from a vegetation standpoint, in 2016 or 17, Grand Canyon National Park did set up a permitting process for associated tribes, those native groups that I mentioned at the beginning of the presentation. They set up a permitting process for a lot of native tribes to be able to come to the park and gather traditional herbs and use them for their various rituals. Some of these things, and not just Grand Canyon, but other national parks as well, were set up because they mean something to us as descendants of settlers, invaders, essentially. They also meant something very specific to a lot of the associated tribes in those areas. And so for them to be able to collect plant material to use ritualistically is very, very important for them. All right, the next question here from Sherm Clark. How much camping happens in the canyon in normal times? There's a permitting process that occurs on the South Rim. Most of the preferred camping areas are kind of down by the river, or what's called the Tonto Plateau, or the Tonto level of the canyon. The Tonto level is not great because there's not much shade. It's mostly very short shrubby brush and some large boulders that really don't offer too much for people to cool off under. Whereas down by the river, we still have those tamarisks. We still have a number of other native trees and brush that people can then camp under. And so under normal times, I'm assuming that that's a reference to COVID, our permitting process fills up very quickly, especially in the main corridor and the actual developed campsites that are within the canyon. The undeveloped campsites, those that we're working on for the most part with these, the LTEMP program, a lot of those, it's a lot easier to get a permit for, but you do need to usually get in line, so. Oh, is burning the brush out of the question? Yes, it actually is. On July 4th of 2018, we had a few folks set off a few fireworks down at a place called National Camp, and it burned. We do get fires in the canyon. It does not happen very often. The burning of wood down there is very heavily regulated by the Park Service. In the winter time, river boat operations, recreational boat operations that go through, as well as hikers, are allowed to burn wood down in the canyon, but that charcoal actually sticks around for decades. And so some of the sites that we go to occasionally, we'll be digging up plants and we'll be pulling up charcoal, and there's no way really for us to know whether it's charcoal from modern times, actual humans these days that had lit a fire within the last few years that then got covered by sand, or if we're actually digging into an ancient roasting pit or something like that, because the dry sand just does not allow things to degrade as much. And so yes, burning is out of the question for the scale at which we're pulling up this arrowweed and these tamarisks and other invasive species. Aside from that, we can have that conversation. It has been mentioned, and we will be talking with our compliance program about that. But again, we don't want to add back that charcoal into the system that doesn't belong there. So. Oh, sure. Yeah, I don't know of any specific that contain natural kerosene. I mean, the pines obviously have that very dry sap, but we don't get those down at the river too much. Arrowweed is in the aster family, and it does have a very strange kind of astringent smell to it when you're pulling it up. It smells like a very potent carrot almost. And I would expect that burns pretty readily, pretty easily, but I've never had a fire in the canyon, so I can't really respond to that. Oh yeah. Okay, so Todd Teachin writes, the tamarisk beetles have been more effective than any other control attempt, as you described here, that is potentially beneficial, non-native, invasive, water use, and problematic habitat. Thoughts? So really, and You said he works for Lake Mead, right? Yeah, so we do have a biological control that's been going on in Grand Canyon. It is the tamarisk beetle. There are a couple different species, and I'm not an expert in them because we did put a kind of hiatus on treatment of mature tamarisks within the canyon for some of the issues that I outlined before. The tamarisk beetle itself was released both east and west of us, so at Lake Mead and at various other places east of us, east of Grand Canyon, and they've been coming down from those side canyons into the canyon itself, and we've been able to kind of monitor and watch the progression of tamarisk beetles as they've come through the canyon. And yes, they are very effective at defoliating tamarisk. My opinion as an invasive plant technician really is that if we are going to make a push to get rid of tamarisk, we do need to have a plan in place to replace it again with something else that's native prior to it taking off with, you know, say Russian olive or a different invasive. We also should be, if we're going to be utilizing the beetle to the greatest effect, we should also be using herbicide on some of those patches that are most affected by the beetle as well, since they're already stressed. So.
Okay, so our time is up. Some people like me have classes. So start in 10 minutes, although there isn't a class in here, so if people want to hang around and ask more questions, that's fine.
Great.
But I want to thank you all for coming. Thanks, Cam. And before we applaud, just put in the plug. Next week's speaker is Zach Edwards, who also grew up in Alfred. Zach Edwards' son, and the following week is Sawyer McFadden. And Zach will not be in person, but Sawyer will.
Cool.
So thank you very much, Cam. That was
Thank you. Yeah. Oh.
I want to stop recording.
Yeah. Thank you all in Zoom land. Michelle just wrapped it up and I'm gonna stop the recording now. If there are any more questions, Cam is still here. Otherwise, thanks all for coming.